This video lecture from the subject of Power System Operation Control, Module 2, Power System Operation. The topic of this video is Base Point and Participation Factors method. In this base point and participation factor method, the system load will keep changing in a cyclic manner. It will be higher during daytime and early evening when industrial loads are high. However, during night and early morning, the system load will be much less. The optimal generating scheduling need to be solved for different load conditions because the load demand P keeps changing. When load changes are small, it is possible to move from one optimal schedule to another using participation factor. The known optimal generation schedule P1 naught, P2 naught and so up to Pn naught. Here the 0 indicating the initial values, the numbers 1 to n are the number of units. P is power demand for the particular load PD. This schedule is taken as base point and the corresponding incremental cost is lambda naught. Let there be a small increase in the load del PD to meet with the increased load. Generation ought to be increased as del P1, del P2 and so on up to del Pn. A small change in power increase or decrease, it will reflect in all generating stations units from 1 to n. This changes will give the del represented by del and the cost, incremental cost is represented by del lambda. In this method, assume that the economic dispatch problem has to be solved repeatedly by moving the generators from one economically optimum schedule to another as the load changes by reasonably small amount. From a given schedule, the base point and the scheduler assumes the load change and investigate how much each generating units need to be moved in order that the new load be served at the most economic operating point. So in the graph itself, we can clearly understand how much the demand will increase, accordingly how much the cost will increment or decrease. Assume that both the first, second and derivative of the cost curve versus the power output functions are shown in this figure. The incremental cost lambda is given for ith unit in the figure. As the unit load is changed by the amount of Pi, the system incremental cost is changed from lambda naught to del lambda. For a small change in power output on this, a single F double dash into del Pi. If for the n number of units, the change in demand is find out from the ratio of change in lambda and Fi double dash. The total change in generation is always change in total demand. Of course, the sum of individual unit changes. The sum of individual unit changes will equal to the change in power demand. This is how the participation factor method will help to find out the optimum solution. Thank you.